Okay. So what we need to do is we need to figure out the logic which is happening at the bottom of this recursion tree. The same logic we can just take down to the top of the uh, till the root of this recursion tree. So if I look at that at an individual level, so wherever I am at any node, for example, if I consider this node, what I do is I primarily look for two conditions. If the current two characters which are being at this node, if they're same, what I do is I spin up a new recursion call at this point. If it is not, what I do is I take a max of these two left and right branch. For example, if I look at this approach or somewhere here, if I look at this node, so here the last character obviously do not match. The R and F, they do not match. If they do not match, what I do is I take the max from the left and right. If they match, what I do is if they match, whatever is the previous recursion call, for example, uh, I actually spin up a new thing. So I take an addition of 1 plus the previous string, assuming that if I consider the sequence of recursion call, here the two characters match. So if two characters match, what I do is I remove them, and instead of that I add 1, and I consider that as increase in my subsequence by 1, and whatever is the largest which I get from the remaining string. So with that remaining part, so remove two characters and go back to the previous string with two characters removed. So what we do is we create a table. Let us suppose, for example, what's the size of table here? What I have is 4. 1 2 3 4. 1 2 3 4. So we have a 4. Let us do one thing. Let us create a table of 5 by 5. Okay, so let us do one thing. We will use this table to store some of the values. We will first figure out a logic based on this table. Then we can. Okay, so for time being, let me remove this. Okay, so what I'll do is we will write the index here. For example, and I want to apply the same for this. Okay, so let me write the index here. For example, if I write index here, 0, 1, 2, 3. I think it's 0, 1, 2, and 3. And here too, I'll write 0, 1, 2, and 3. So I'll be using this table to indicate the index at which my array would be there. So what I do is, so whenever these values are passed to us, this the index values which I have written there, this I will use to refer n and m. If you recall our program, let me get back the syntax of our program. So if you look at our program, what are the thing which we have here? LCS of start S1 and S2 and N and M. This N and M, this N and M will be denoted by this two, the first column here and the first row. So think of these values 0, 1, 2, 3, and 0, 1, 3, the index of this two-dimensional data structure, as denoting n and m for the table. So what we do is we start computing the values for first the bottom values. For here, if I consider these values here, for example, if I consider any of this, for example, if I take back and if I consider the root of this, so a and a, if I look at a and a, it is 0, 0. So this value, whatever I have computed for a and a, that will appear at this point. I hope you're getting that. And let us suppose if I want to compute a value for this value. If I want to compute a value for this value, 0 and 1. So 0 and 1. So AF and AF, it stands for that string. So if I go for 2 and 3, it means 2, 3, GR and RZ. So these two strings are compared when I am at this location 2, 3. So now what we do is whenever I am at 0, 0, so 0, 0, I can fairly look at that. So if I talk about 0 and 0, um, now initially if you consider 0 and 0, the table will be all, the entire table will be filled with zeros. So nothing is matching. Then once the entire table is filled with zeros, what we do is this would be the initialization. Okay. So once I initialize that, okay. So once I initialize that, now I can proceed with an iterative approach. So assume that I start with 0, 0. So if I start with exact 0, 0, what I need to do is I need to first compare the values at that point, exact point at which I am at. So then after, uh, so then after what we do is, mm, we start comparing the values which we had in our code. So if I look at the block of code which is responsible, let me get that block of code here. Okay, let me paste that block of code somewhere here. Mm, okay, I think the block of code. I think just a minute. Okay, so I think now you can look. So what we are trying to figure out, how we will figure out this recursive call. So this is a call to n comma m. So whenever I get n and these two characters, what I'll be doing is I'll have to check the n minus 1 and str of n. So whatever n and m which I get. So for time being, forget about this n minus 1 and m minus 1. Provided whatever the n and m we get. So we are right now we are not looking at that indexing. For example, whether it is 0 index or 1. Assume that we get two indexes here and we are checking the equality of the two characters. So if I want to check equality of two characters, if something is equal, what I do, sequence of n minus 1 is equal to, I have added that matched character. Then what I am doing here, the memoization of n is equal to 1 plus LCS of this. So it is 1 plus, what I have done, 1 plus LCS of str1 and 2 n minus 1 m minus 1. So if I say I have reduced the number here, so let us assume I am at this location. For example, I am at this location, and here at this location the characters match. Maybe I want to say that character at index 2 and character at index 1 match. Or example, let us do one thing. Let us take a example where our characters match. For example, it is 0, 1, 2, and 3. For example, let us do one thing. 0, 1, 2, 2, 3. Okay, if I consider this location, if I consider this location 2 and 3, here this characters match. So at location 2, if I denote this row wise indices to point to str1 and column wise indices to point to indexing of str2, then 2, 3, if I check this value, here this character R and this character R match. If they match, what I do is I add 1. So the value here would be 1 plus, look at this, 1 plus LCS of str1 n minus 1 m minus 1. So if I do m minus n minus 1 m minus 1, what cell I am referring to that? N minus 1 and m also minus 1. So m minus 1, n minus 1. So it is like diagonally going to the top left corner. So this cell, if the characters are equal, then what is the value? It would be 1 plus the previous diagonally top corner. So I'll call it as diagonally top corner. Let us suppose if these two characters do not match. So the characters which are referred by this location cell, if they do not match, if they do not match, then I have to look for this kind of block. What I do, str1 1 n minus 1 m and n m minus 1. What will be that? So if I retain n as it is, for example, let us say this is n, I want to say the row number, n I am retaining same and I am doing m minus 1, means this cell. So this cell, and if I take if I retain m as it is, if I retain m as it is and I do n minus 1. So if this is n and this is m, assume that this is n and this is m. So n minus 1, row minus 1, and retain m as it is, this one. The second one, retain n as it is and m minus 1. M minus 1 means one column less. So I come to this cell. Okay. So what value should I include? Whatever is a maximum of this two green cell, it will come in the yellow cell. If the characters which are referred at the indices of yellow cell, they differ, if they are not equal to. If they are equal to, what happens? If they're equal to, what I do, I need to include the value here, which is nothing but 1 plus whatever the value I have in the orange cell. Are you getting this? So what we do is we start with the top left corner and we keep on building the cells as it is. We keep on building this, right? And the moment we reach at this point, we get our final solution. So whatever the value which we'll be having at this final 3, 3 cells, or let us call it as n comma m. If the strings are of different length, then this matrix can't be a square matrix. It could have a different n and m. So what are the cell value which I've had at the top, bottom, right corner, that gives me the solution, which is the length of longest common subsequence. So what we do, we start at this location, the top location, because we start building on previously computed values. So if I'm at the yellow cell, you can understand that these two values should be computed before I compute yellow cell. So what we do, I started this. For example, I started this location and I keep on solving them till I reach to the final cell. So this red colored cell is where I get my solution. Okay. So let me check your response. Have you understood this logic? Okay. Any question to the remaining students? I hope you are understanding that. So from recursive approach, one which we're able to look at the recursive call, now we are converting into tabulation method. So this is a particular feature of dynamic programming. Whichever dynamic program which can be solved by using recursive memoization, that we can always solve by using a tabulation method. The recursive and memoization approach is called as top down and tabulation method is called as bottom up. Now why we call this as bottom up? The reason behind calling this as bottom up is I start from the node. So whenever I'm at 0 0 or 1 1, what happens is I start at the bottom and I keep on building solution to the top problem of that. In case of recursive, I start at the full problem, I start splitting it, then while coming back to the recursion chain, I start building that. So recursive approach is always called as top down and this tabulation method is always called as bottom up approach. So any questions to other? So if no questions, then we'll start writing that in a Python program. We will convert that into a tabulation method. So now, before we jump to the Python program, let us see how we have to structure our table. So initially, now this is the approach roughly we have discussed. Let us think what will be the logic if I want to start with 0 index and 1 index. Okay, so I'll mute for a few seconds, just think of that logic. I'll come back after 30 seconds. Yeah, I have muted because I have some background noise. So I'm just solving that. So what I want you to think of is uh, initially we had the 0, 0, right? But if I think of this approach here, if I think of the recursive approach, I'm starting with n minus 1. Okay. So I want to ask you, what should be the exact approach? Okay, so I hope you understood what's the problem I'm looking solution for. So if you look at this, we have seen the logic for 0 and 0, but remember our strings are 0 indexed. And if I'm at 0, 0, how do I look for that n minus 1 and n this minus 1? As you have seen that at any point for this 0, 0, do you see the 0 and 0? If I see 0 and 0, you can see that for this yellow colored cell, it depends upon these two green cells, this cell and this cell, if the characters 0, 0 are different. If it is same, I need to go back and I need to add 1 plus the diagonally top cell. So which is the orange cell, right? So when I start implementing this table in Python, I won't be having -1 indexed. So I need to figure out how I need to structure my table. Since -1 minus will not be a good thing. Okay, theoretically I can solve -1 means n minus 1 means m of -1, that's fine. But in a list, if I access list of -1, what does it refer to? So it refers to a different location. So I don't want that index to be -1. What I want is, how do I structure this? Do you think that if we start it with 0, will it make sense if I start with this 0, 1 and 2? If I go by this approach, do you think it will work? Now my string will no longer be 0 index. I need to refer almost if it is 1 indexed. So if I figure out, then writing program will be far more easier. So this is what I was talking about. Okay. So what should I do? -1 or 0, 0? -1 is obviously not a solution. So what I'll do is, I will not refer them by -1, but I'll refer them as 0, 1. I'll refer the 0 row and 0 column to denote the first dummy values for that. Only then I would be able to write program without making it complex. Okay. So if this is the case, if we move this, and if I want to use 0, 0 as something, um, let us suppose if I want to include 0, 0 as something where just after this boundary, if I want to include just after this boundary, then I would be referring them as first characters, second, third and fourth. 0, 0 I want to refer something beyond the first index. If that's the case, what will be the default values for this? 0, 1, 0, 1. If it is the first thing is 0, then everything will be 0, which means that one of the string is null and other string is having some characters. What we have taken, what we have shown in that approach, if one of the string is null and other is, if one of the string is null and if other we have some string, what's the total value will be always 0. So if one of the string is 0, the entire thing will be 0, 0, right? So here too it will be 0, this 0, and this will be even this will be 0. Okay, so I hope you're getting this logic. So I'm also capturing these values as well. If one string is 0, then entire other string, even if the other string is of character 4, the subsequence length will be 0. Here too it is. So I am referring this as n and this as m. Okay, so let me have that approach well identified here. Let me make a small space for it. Okay, so this one here, I want to make it clear. This I will indicate m, which is length of string 2, and the same here it will be n and m. So this length I'll denote by n, and this I'll denote by m. So now it should be a little bit more clear to you, right? So this is n and m. So at any point, if I'm referring, if n is 0, then no matter how long the second string is, obviously the length of string will be, subsequence will be 0 and 0. So now I think I can work for 1 and 1. If 1 and 1 is same, yeah, check the first character, 1, 1, 1. Is it same? Yes. If it is same, what I do? I check the diagonally top values. What is diagonally top value? 0. So 1 plus the value inside diagonally top value. What it is? 1 plus 1? 1 plus 0? It would be 1. Okay. So initially all these values will be 0 and 0. Let me copy paste. All these values will be initialized to 0. So we start from this cell, which is the yellow colored cell. So what I said, it would be 1 plus the previous one. So now after computing this, what I'll be computing? I'll be computing this cell. So when I compute this cell, okay, so this colored cells would be slightly different. Let me repeat it just for this. So I want to compute for this cell. So what I do here, as I said, if characters are same, then diagonally top. If not, greater of these two green cells. So what I'm looking at? I'm looking at this value. So n first character, and from m two strings. From m a string of 2 length, and from n the first one. So what is the status of these two characters? Last characters a and f. Are they same? No, they are not same. If they are not same, then I take max of this two. So what is max of this two? 1. If they are same, I will be moving at the 1 plus diagonally top cell, diagonally left top corner cell. Okay, so this table moves on from this, here, then here, then here. So at the end, the table ends at computing value for this final cell. This final cell should give me the result of my longest common subsequence. Fine. So now, since we have figured out this index, now let us write a Python program for it. I hope you understood. So I want you to just guide me how I can start writing, or how I can start structuring my Python program. Okay, let me share that window. Okay, let me open a new Python file. Let me go to LCS tabulation method. Okay, so when I am at this tabulation method, what should I do? Let us suppose if I have the same strings str1 and str2. Okay, so this will act as an input, str1 and str2. Now I need to write this in an iterative method. So I need to take this table. I need to define this table. What is this table? It's a list of list as of now. If I want to define a two-dimensional one. So how do I create a two-dimensional table of rows equivalent to this string and columns equivalent to length of str2? Can you suggest that quick syntax? I hope we have seen this two times earlier to this. Now it is third time we want this requirement. So how many rows I want? Rows equivalent to length of string 1 and columns equivalent to length of string 2. What should I write here? And I want all of them to be initialized to 0. So here what we are doing, create the table and initialize the values to 0. So can you tell me what should be? I want to create rows equivalent to number of rows equivalent to length of string s1 and columns equivalent to length of str2. Suggest me the syntax. Just it's a simple two line, one single line. We will be what we will be using? We will be using list comprehension. Can you suggest that? Why I'm asking? We have already discussed this revises the Python syntax. So I'll wait for your response for this one. So this will be one row, this will be another row, this will be third row, and so on. How many rows such I want? Based on length of string 1. And number of columns means I'm talking about this internal values. This will be based on length of str2. So what should I write here? Inside this and outside this. Can you get me the answer? We have already seen that. That's why I'm asking you. We did it for some program. I think, if I'm not wrong, we did it for zero and knapsack. Can anyone at least go through that program and give me the answer for that? So I'm just writing the further step. I want this answer from you. Can you go through and get me the answer for this one? Okay, so Gurnath has done. I appreciate that you have done that. Okay, so what you are saying is table is equal to 0 for I in range length of str1, and this you will repeating for j in range length of str2. Let me take that and let us see if that's the right. So what you're saying is this. So what he has said is 0 for I in range. So these many number of times 0 will be repeated for I in range length of str1. What is str1? It is, let us suppose I want to denote this length as n, and I want to denote this length as m. If that's the case, if this is the case, then how many rows I was asking for? If I want to look at the table one, I was looking the number of rows are based on length of str1. So the number of rows is determined by, this is row 1. How many times I want to repeat this? This I want to repeat it for n, which is n is length of str1. So here I would be having str1, and columns I want to be equivalent to length of str2, which is length of m. So this 0 will be swapped for str. This will give me the exact table. So you can even check this. If I want to print this, you should be able to check the output as well. So let me print and just verify if okay. So 1 2 3 4 5 6 7. So 1 2 3 4 5 6. Okay. So likewise, you will find 1 2 3 4 5 6 7. Yeah, I think we are getting the proper table structure. So that's fine for us. So now we have a table. What we will be doing is we will continue our logic. In the tabulation, if you see that I am building them row wise. First row, then I calculate value for second row, then I calculate for third row, and in the end I calculate for fourth row. And when I start with first row, I start with the first column and I move on calculating values till the uh, end of that one. So how I'm starting with? I'm starting at this one. I start computing rows till I reach to this point. Then I started second row. Then I move to the end of that. Then I started third. So on I move. So this is how I keep on calculating values cell by cell. So if I want to move this in this way, row wise and column wise internally, if I want to move it in this order, what should be my the loop structure? So outer one is for rows. So if I want to move it for rows, how am I moving that? I in range, I in range. For time being, let me calculate. Let me store it for ease of use. Let us call it as str1 and say m is equal to length of str2. Let me do this for ease of use. So wherever it is str2, instead of that, this won't be giving any performance, but code will be far more readable based on our logic. Okay, so I want the outer loop to be repeating row wise. What is the row here in my case? N, and I want it from 0 to n. And in range, if I say n, it is always exclusive. So I will say n plus 1, right? And here I would do m plus 1, right? So inside this, whenever I enter, what's the first thing I need to do for? if check if the characters match. The same logic. Check if the character check if the last character match. If it matches, then it's just what I do diagonally sum of top one. So how do I check if it matches or not? So I am starting it from I is equal to 0 and 0. So do you think we have to start with 0 or we have to start with 1? Here, do you think we need to start with 0? If I start with 0, then my diagonally top will be of minus index. I don't want that. For that purpose, what we have done, we have specifically started this from 1, because for first cell I have included it as dummy 1, right? So I'll say 1 comma n plus 1, 1 comma n plus 1. If that's the case, then I need to also include more number of rows, right? For to accommodate the dummy row 0 0 and 0 0. So okay, so here I'll start with 1. I hope you're getting the logic why I'm starting with 1. Then what I need to do, if str1 of I, if I check for I equal to str2 of j. Now since the index is 1 plus and our containers are index 0 index, I'll be checking it for minus 1. Since they are 0 indexed, I'm just putting them minus 1. Okay, so if it is that, what I want to do, inside table of I and j, table of I and j, uh, table of I and j is equal to 1 plus, if they are equal, what I do, 1 plus I minus 1 and j minus 1, if they are equal. If they are not equal, else, inside else block. If they are not equal, what we do, table of ij is equal to max of what are the two cells, the two green cells which you have seen. Retain I as it is, j minus 1 and I minus 1 and j, right? If beyond that, okay, so we have returned okay, my then j moves to the end, and okay, so once this all is done, I think the only thing is to just print the value. So if I'm out of this, I think the only thing I can do is print length of longest common subsequence for S. Okay, let's see, for str1 and str2 is something. Let me do in a formatted mode. What the first argument I'm saying is I'll pass str1. The second argument in the curly brackets is str2, and third where I'll be having the result. which would be table of N and M. The table of N and M will contain the length of the string. So STR1 length table initialized approach. If it is that, then I take two max values and ij increment. Okay, let us say, let us run and see what's the output expected for this. A F A F A F R. What's the length maximum one? A F. I think okay. Okay, so the length of longest common subspecies for this and this is 5. Is 5 right? Okay, let me see some other test cases which we had on that day. What will be the output for this string? We'll check multiple strings for this, and let me take one more cell. Okay, what's the output for this one? It should be 0, right? And what's the output for this? The output for this was 5, and I feel it's correct. We'll check for this. It should be 0. Okay, I'm getting the length as 0. That's fine. Now I want to make it work for this. Okay, what's the length you're expecting for this? What's the length? It is A and A match, D and D match, and what I think it should be 2. It should be only 2. A D. Okay. Okay, I think what's happening here. Okay, so here duplicate characters are adding. This will just keep on adding that. I think when last time when we solved for this for recursive, I think we were to figure out run LCS recursive. Okay. A D A S S. Okay, so it matches twice. So for the duplicate characters, we have to figure out a line which solves that. A and A. I think you can see that because it has a two sequences. The problem is that two sequences match. A D to this substring, it matches to this string, and this substring here also matches to this. So it goes into another problem where we call print all longest common subsequences. Then that depends upon the table and what we do for that. So, but here if I want run tabulation, it is giving me 3. Is what it is? Actually, it should be. It's adding unnecessarily. It's adding this one additional for this one, since we have a repeating sequences. Okay, so can anyone suggest me how I can bring this down to 2? So here these two characters match. and somewhere it matches this. So for this string, I think let me do one thing. If I make it even smaller one, okay. So let us suppose if I say AS, okay, now I get this. So as long as I have this string, I get 4. What you need to do is we need to figure out this condition. Needs to check for occurrence of multiple LCS of same length. Okay. I didn't get Akash answer. So what Akash was saying is answer of, for this thing he's saying answer 3 is right. What am I missing any character here? Okay. So now it's up to the okay. Okay. If you are saying, okay, I think I missed this, is A. So I was looking at these two double occurrences of this ASD and AD and AD. So I think here you have considered this S. Okay. Okay. So 3 is also fine, and the sequence is ASD. But remember, the problem which I want to work on is a case where we have multiple LCS with same length. This we have to figure out this logic. So a case where we have multiple LCS with same length. There could be multiple longest common subsequences as well. Okay, case where multiple LCS with same length. Okay. Okay, I think this program is working. I hope you understood how we can implement this in iterative approach. Okay, so just what I want is I want you to work on this case. Just look for this case, and where we try to figure out what exactly is a sequence. As a homework, I want you to figure out the exact sequence. So as a homework, what I want is print the sequence as well for this program. Okay. So you can figure out how you have to figure out the character in this case. In this case, we saw these two values, right? Dictionary, container, store that in ordered one and that. But here, how would you figure out? It has some different method. So I leave that to you to figure out how to print the exact matching sequence in case of tabulation approach. So I want the solution for both recursive with memoization and LCS with tabulation. For both, just figure out how you're gonna print the length. I mean, when I say length, I mean the exact sequence. We are printing the length. I want you to print the exact subsequence.